Algebra 1, Chapter 4.3. We're going to talk about parallel and perpendicular lines, guys. So, parallel lines, guys, are non-vertical lines that have the same slope. So, those can be parallel lines. Now, granted, they're drawings, so they're not perfect. Two horizontal lines have the same slope. Even, I guess, vertical lines, two vertical lines, even though it says non-vertical parallel lines have the same slope, sorry. Non-vertical parallel lines will have the same slope. But, basically, these are all examples of parallel lines. Parallel lines just go in the same direction. So, it's just the fact that if it's non-vertical, which means it does not go up and down, because vertical lines don't have a slope. That's why. My bad, I jumped a little bit. So here's a cool thing. They have the same slope. Therefore, I can look at an old equation and say that if something is parallel to that equation, that means the slopes have to be the same. That means if I know the slope of the first line, I know the slope of the second line. So, look here, and it says, write an equation in point-slope form for the line that passes through the given point and is parallel. And so, if it's parallel to that graph, and it wants it in point slope, not slope intercept, so that means it's a cue to me to say that I'm going to leave it in this form. Okay, so look here. This line, this is the old line. There's a line that's going to be parallel to this guy, but goes through that particular point. See, here's a really cool thing. Sometimes I'll even trick myself and say old slope equals 1/4. And then I'm going to say, what's the new slope of the new line? And then you start thinking, wait a minute, if they're parallel, it has to be the same. And then I put the point that I copy right down, and that's 4, -1, and I now can write the equation because I got a point and I got a slope. And so I'm going to use y minus y1 equals m times x minus x1 and start filling it in. So y minus -1 equals 1/4 x minus 4. Now, technically this is in point slope form. The only thing I would possibly do is change that to y plus 1 and then leave it as 1/4 x minus 4. And then that's done. Now, unless it says put it into slope-intercept form or standard form, leave it. Now, it does say to stop here. If it didn't say, it just says write the equation, then please, by all means, put it into slope-intercept form. But it does not ask us that. The next one is in standard form, and it is not in a form readily available to get the slope. So you're going to have to find the slope. And to find the slope, the easiest way or form to put it in is just put it into slope-intercept form. So y equals mx plus b. Now y equals mx plus b. It means y is by itself. Y is not by itself, it's with some x's, and it's got a 2 in front. So let's just take care of that. So the first thing I need to do is I'm going to take care of the 4x. How do I get rid of a positive 4x? Is I subtract 4x. So therefore, 2y is equal to -4x plus 8. Remember, I always put the x's first, highest to lowest power. Later on, we'll learn that it's called standard form of a polynomial in a way. So bear with me, there's a lot of standard forms and different things. Now, I got to get rid of the 2, because it's 2 times y. To get rid of times 2, I'm going to divide by 2. Don't forget that when you divide one side, you have to divide the other, and on a particular side, you have to divide everything by 2. What's -4 divided by 2? That is -2x, and 8 divided by 2 is 4. So I get y equals -2x plus 4. And so the old m equals -2. The new m is also -2 because they're parallel. And so y minus y1 equals m times x minus x1. Oh wait, the point that we want to use was -3, -2. So we'll have to clean this one up in two spots. Y minus a -2 equals -2 times x minus a -3. So y plus 2 equals -2x plus 3. And then leave it because it says point slope form. So that's pretty easy enough. Make sure, take it one step at a time. On the flip side, perpendicular lines, guys. Perpendicular lines are lines that meet at 90 degrees. So they don't meet, they're not side by side, they meet at 90 degrees. And sometimes they put that little 90-degree box in there. And guys, the slopes of non-vertical parallel lines actually are opposite reciprocal. Opposite reciprocal to each other, which means if one slope was 2, then the other one is the opposite, so it's -1, and reciprocal 1/2. Flip it. It's the opposite reciprocal, opposite flip. So 2 and -1/2. -4/5 is the same, or has a perpendicular as 5/4, positive. Okay, so don't say negative reciprocal, because if it already is negative, then it becomes positive. So that's why I like it in the opposite reciprocal. Vertical and horizontal lines themselves are considered to be perpendicular. They'll meet at right angles. And the product, here's a cool thing, the products of the slopes of any non-two vertical lines is -1. Think of this, what's 2 times a -1/2? The 2's cancel and you'll end up with -1. If -4/5 is multiplied by 5/4, the 4's cancel, the 5's cancel, and you end up with -1. So when it comes down to this, it's the same steps as before. I still got to find my old slope, but then what I'm going to do with it is I'm going to take that old slope and make it new by making it the opposite and then taking the reciprocal. So on this particular example, they're not actually asking you to find the perpendicular line. It actually is asking you to tell, are these lines perpendicular? So in this particular case, it says that a plans for a treehouse, a beam represented by QR has endpoints at Q and R. A connecting beam represents ST has endpoints at S and then T. Are the beams perpendicular? So if you think about it, I need to take these 2 points and these 2 points and find. So what we're going to do is just find QR slope and ST slope. If they're the same, they'll be parallel. If they are opposite reciprocals, then they're perpendicular. And if it's anything in between, then they're just not. Neither. They could be some form of lines that eventually could cross, not cross. So here we go. If we're going to do this, that means we need to find slope. So I will write down that slope formula again, of course. And to make this a little easier for me, I'm going to call that 1.1 and that 1.2. And that's the ones I'm going to use. So 8 minus 2 over -1 minus a -6. And I get 6 over not negative, because 2 negatives make a positive. Almost made that mistake. And so I can take this out of here, and it'd be 6 over 5. So a -1 plus 6 is 5, yes. I'm going to do the same thing here. I already have the slope formula on my paper here, so I'm just going to plug my numbers in here. I'm going to choose 1 and 2. So 5 minus 6 over -8 minus a -3. So this is interesting. So 5 minus 6 is -1. And 2 negatives make a positive, -8 plus 3. So someone owes you $8, gives you $3 back. They still owe me 5. 2 negatives dividing, negative divided by negative will make a positive, is 1/5. So unless I did something wrong here, it looks like my numbers should be correct. I get the first line is 6/5 slope, and the second one has a slope of 1/5. They are neither the same, so they're not parallel, and they are not opposite reciprocals, so the answer is no, because they're not opposite reciprocal slopes. So I'm not going to actually do this one to its entirety, and basically they want to determine whether the graphs of the three equations here are parallel or perpendicular to each other. So some of them may and some of them may not be perpendicular or parallel. So obviously on the second equation, it's really easy to see that the slope of this, because it's 3x minus 4, the slope is 3. We should also recognize that the slope of this y equals 4 is a horizontal line, that's y equals 0. The only thing left then is to find the slope of this line. And to do that, you will put it into slope-intercept form. I highly suggest you add 2y. Actually, let's just do the problem. Add 2y. So I get 6x equals 2y minus 2. Add 2. So I get 6x plus 2 equals 2y. Divide everything by 2. 3x plus 1 equals y. That means the slope is equal to 3. So that means we know that these first two lines right here and here are parallel. None of them are perpendicular because none of them are opposite reciprocal slopes. So that's easy enough to do. So it looked like a very daunting problem. I was just going to explain it because there might have been a lot of work, but it actually turned out to be pretty simple. Now, as in this one, they actually want you to write the perpendicular line. So I need something that goes through this point, L4, 7, and is perpendicular to the line y equals 2/3 x plus 13. So again, whoops, I forgot to write old. M equals 2/3. New M equals opposite, so negative this time. Take the reciprocal. And we're going to go through the point 4, 7. Now, notice that this time it wants the slope-intercept form. So yes, you have to finish it to y equals mx plus b. But I'm still going to start off with y minus y1 equals m times x minus x1, which is point slope. So y minus 7 equals negative 3/2 x minus 4. I'm going to start to distribute, so y minus 7 equals negative 3/2 x. A negative makes a positive, and I'm going to say 3 times 4 is 12, divided by 2 is 6, so plus 6. I'm going to add 7 to get the y by itself, and so y equals negative 3/2 x plus 13. You've now created a line that is perpendicular to the original line but goes through the point 4, 7. This is the last slide before homework. I'm just trying to put it all together for you. We got parallel lines here. This symbol right here, which looks like parallel lines, is what we use to represent parallel lines. And over here we're talking about perpendicular lines, and it looks like an upside down T. That represents perpendicular lines. And as you can see from here, there's a little 90-degree box there because perpendicular lines meet at 90 degrees. Homework. Let's take out this middle section. I'm okay with that not being in there. And what I want you guys to do is that the first two problems, they want you to be parallel, and it's in slope-intercept form. The second two, it wants to know whether they are parallel, determine which of the graphs or equations, kind of like that third example we did, which one of these are parallel or perpendicular. And in the last ones, let's do just those, 8 and 10. And they also want that in slope-intercept form. So those 6 problems is what I like to do. Have a great day.